Welcome, my name is Fabian and I'm going to talk about how you extend the Horion architecture design to support additional Horion Suite components. We have talked about the Horion pod architecture, and we need to make sure in the physical design that we keep it kind of extensible for other Horion solutions. How can we integrate there more probably with each other? So one very important thing is that we have a load balancer in place. Why do we need the load balancer? Nearly all Horion components, connection server, security server, unified access gateway, identity manager, app volumes manager, they need a load balancer to kind of increase the throughput transparent for the end user and to increase the availability. Since the load balancer is configured with a so-called health check, it does a health check to the back-end services that can be the connection server. And those health checks will figure out if the service is running. If it's not running anymore, it does kind of a failover. It disables the node and all new connections are transferred over to the other node. And this is a concept that is very crucial to understand. That is a concept that must be configured probably in the physical design phase. Why? We need things like session affinity. We need to make sure that the end user has always the same connectivity endpoint when he does a connection to his virtual desktop. Why is it that way? Let's have a look at the connection server connection flow itself. I, as an end user, use my laptop here to connect against the virtual IP address or the FQDN of the load balancer. That's the first phase of a connection. The load balancer picks one of the connection server and does all of the authentication after I typed in my credentials. What's now happening for having access to the remote or to the virtual desktop over a remote protocol is that in the second phase of the connection, a new connection is established, and that connection always needs to go over the same connection server where the first phase has been dealt with. That means we need to have some session affinity configured that everything works properly. Another very important thing is here to make a correct configuration of the connection server external URL things. So we typically need to include the external URL of the load balancer into the connection servers. That's an important thing we need to consider, and we need to decide how we deal with SSL topics. Do we do an SSL offloading on the load balancer where we need to place our certificate, our hopefully enterprise certificate authority signed certificates on the load balancer? Or do we do something like an SSL pass-through or have the SSL endpoint on the connection server where we use the locally in Windows installed SSL certificates? That's quite very important design consideration where we need to figure out what kind of network characteristics we are having and what kind of security policies we need to fulfill. Important, the connection server is joined to the Active Directory domain. And is placed in a secure LAN network within the internal corporate network. We do not expose the connection server somehow over or to the internet. When we talk about another very important Horion component, that's the view component. The view composer is always used when we need desktop pool. The link clone itself is a virtual desktop that only has a that has a large footprint in the parent VM, in the replica VM, or in the replica file, and every single desktop instance has a very small footprint, since we only create a small snapshot or a small delta file that makes up in the end our single virtual desktop. The View Composer is required for those link clones. We don't need them for the instant clones. That's very important to understand. And the View Composer must be installed on a Windows machine. Now, there is a certain physical design decision we need to make. Do we install the View Composer on the same Windows machine where other components are installed? For example, the vCenter server. The vCenter server can be installed on Windows, even though that is kind of deprecated. That is something we do not prefer nowadays. So we need to make sure that we install the View Composer on a dedicated single Windows machine with a proper sizing, so that we are ready for future vCenter server design considerations we will make in our environment. And remember, there are ways to migrate the View Composer from one machine to another machine. So there are options where we can do that. We utilize the Composer database backup. We need to export some RSA security component and import that at the new machine, recover the database on the new machine, or recover the database on the new machine, and then we can make this dynamic switch over of our View Composer. That works pretty fine, and we should consider that in a greenfield environment right from the beginning to install the Composer on a dedicated Windows machine. We do not install the Composer on any kind of connection server machine. Keep that in mind. So, when we design the Horizon View Composer, we need to be aware of any kind of constraints. So, typical constraint is that we support up to 32 ESXi hosted per View Composer cluster. That's one constraint. Up to 2,000 link clones per parent virtual machine replica. And for certain data stores, we have different limitations as well. If we have link clones on a VMFS LAN, we only support up to 128 LAN. When we have link clones on a VMFS data store, we only support up to 128. If we have link clones on an NFS-based data store, we support up to 180 to 250. We should typically always ask the underlying storage vendor for any recommendation based on link clones that we use in our environment. Another important component is the View Security Server. The View Security Server allows secure access of an unsecure network. The View Security Server is typically placed in the DMZ of our corporate. The View Security Server also has those settings we know from the connection server, like external URLs for PC over IP, BLAST, or HTTPS tunnel. We need to configure that properly. And it's also important to know that the security server is not joined to the Active Directory domain. The security server is not joined to the Active Directory domain and should be probably hardened since it's directly exposed to the internet. It's a Windows machine. There are some things we need to consider. We need to follow best practice of our organization when we place a security server in the DMZ. Since it's a Windows installation, we can either install it as a virtual machine on a DMZ vSphere cluster, or we can also install it theoretically in a physical DMZ machine, which typically is not the best design decision in certain scenarios. But it really depends on the requirement in the end. Important, we also need to add a load balancer in front of the security server so that we have, again, the higher availability and the higher scalability. There's one limiting factor with security servers. We need to create a one-to-one pairing, a one-to-one relationship between the security server and the connection server. And that really creates some not very flexible design characteristics that we might want to mitigate. How do we mitigate them? By utilizing the Unified Access Gateway. The Unified Access Gateway is the modern approach to allow secure access of an unsecure network. It is an appliance, a virtual appliance, also deployed in the DMZ, And again, it has the same functionality. It allows us to create a secure access over an unsecure network. It integrates a second factor authentication right at this level of our access gateway. So we can configure radios, SAML authentication, RSA secure ID directly on the unified access gateway. At the same time, we don't have this tight coupling between the connection server and the UAG. So we can place multiple UAGs in the DMZ and can connect them to a load balancer that is in front of the connection server. And that really, the whole configuration makes it much more easy scalable how we design our management block. Because now we can place 4 UAGs in the DMZ. We can have 4 connection servers in the backend and still create a scenario where internet users have a tunneled connection to their desktop over the UAG, while all the internal users use the same connection servers and have a direct connection. That's only possible if we use the unified access gateway. So that's really a design decision that we need to consider. From a physical point of view, we need to figure out how the DMZ is structured. How many networks do we have in the DMZ? How are the backend and front-end firewalls? What physical characteristic do we have there? Do we use a single NIC, dual NIC, or 3 NICs for our UAG appliance? Important, we can align to all kind of network characteristics to deploy our UAG within the DMZ. We need to consider which DNS service to use. How does the UAG recognize the FQDN of the connection server load balancer? Those things are characteristics we need to figure out in the physical design. But we are really flexible in our options here. When we talk about the App Volumes Manager, we also need a load balance in front of it to increase the availability, to increase the performance when a user logs in. Because typically what happens is a user logs into a virtual desktop, and if an app stack of an App Volumes Manager is assigned to this user, the App Volume agent within the guest operating system contacts the App Volume Manager. The App Volume Manager goes to the vCenter server and mounts the proper app stack VMDK into the virtual desktop. The VMDK is now mounted to the virtual desktop. With the App Volume agent, the application is integrated into the guest OS, and all the applications are suddenly appearing within the guest OS. So to increase the availability, we need a load balance in front of the App Volume Manager. The App Volume Manager needs a database. Therefore, we should have a high available database. We only support Microsoft databases for that. And therefore, we recommend to use the always-on SQL cluster for the App Volume Manager. To optimize the performance of the logon speed, we can define that the App Volume Manager should not mount the VMDKs over the vCenter, but it can go directly to the ESXi host where the virtual desktop is running and mount the VMDKs directly over the ESXi host. That requires a certain characteristic on a vSphere level, no lockdown mode or any kind of exception user, but that increases the logon performance tremendously. What else? If we want to have if we have a Horizon pod architecture where we have multiple resource block vCenters, that's a legit design as we have described it before. We need to integrate our App Volumes Manager instances with multiple vCenters. That works probably, but we require unique ESXi host names. We require unique data stores and the same vCenter logon for our different vCenter servers. And that's the last point I want to talk about. The vCenter server should have a user with a proper role configure that has the minimum privileges that are required for App Volumes Manager. So we create a new service user, we give it a role in our target vCenter or our target vCenters, and give this role the minimum amount of privileges that are required. We're not going to talk about which privileges those are in this video, but check the App Volumes Manager documentation. It's defined which privileges are required for App Volumes to work in a securely manner. vRealize Operations for Horion is used to offer an operations team to analyze performance information quickly, to do capacity planning properly, to get quick insights in a complex design, in a complex system architecture. And we have a complex system architecture. We have different layers of performance affecting factors. We have servers, we have a virtualization layer on top of it, we have storage, we might have storage virtualization. There's a lot of things that we need to consider, and that's something where vRealize Operations for Horion can help us easily. What do we need? We need vRealize Operations Manager. In the physical design phase, we now need to specify the size of this operations manager. We need to specify the architecture. Do we have a one-node VROps manager? Do we scale the data out of the VROps manager? Use the VMware VROps sizing tool to figure out the right number of the VROps environment. What else? We need to define where we install the Horion adapter. Will it be installed on the operations manager itself, or do we use a so-called remote collector node where we install the Horion adapter and send our Horion adapter informations from our desktops, from our connection server? This is something we need to specify. We need to apply then in our physical environment. Where do we install the broker agent? We need to install the broker agent on a connection server, on a single connection server. So we typically utilize any kind of connection server in our environment where we install the connection broker, we configure it properly to communicate with the vRealize Operations Manager Horion adapter, and we need to make sure that the firewall ports are open, or that the connectivity ports are open by any kind of firewall that might be in between those two networks. And for sure, the desktop agent or the VROps component must be installed in our virtual desktop. We can either use the standalone version, or we use the VROps component that can be optionally selected when we install the Horion agent in our virtual desktop. Important, as soon as we go to a high number of virtual machines, and we talk about around 5,000 desktops, we typically install the Horion adapter on a remote collector to make sure that we have a proper performance and a proper stability of our vRealize Operations environment.